Hi everyone, in this video I will explain the LeadInOut parameters which control how the tool approaches and departs from a contour profile. The LeadInOut page is part of the mill or router toolpaths that have a tree view list. LeadInOut serves the following purposes. Allows the tool to start and end its cutoff of the stock material so the tool does not have to cut while plunging, prevents a mark on the finish profile caused by the tool plunging and retracting on the finish edge of the part, and allows cutter compensation to be activated and deactivated of the finish profile. Perpendicular LeadInOut provides an acceptable way to activate cutter compensation. But a main disadvantage of this method is that it may leave a small dwell mark on the wall where the tool engages the profile. Tangent line and arc combination uses a small linear move to turn compensation on and off, and an arc move to smoothly blend the tool on and off the part profile as shown. Most controls will not allow cutter compensation to be turned on or off with an arc move. You must use a line. For control compensation, the line length must be greater than the radius of the cutter. The LeadInOut dialog box is split roughly in two halves. The left controls how the tool approaches the cut, and the right controls how it exits the cut. The double arrow buttons allow you to copy the entry values to the exit values or the other way around. And the swap button allows you to swap entry and exit values. Enter, exit at midpoint in closed contours starts and ends the toolpath in the middle of the first entity chained rather than at the end point. Gouge check checks entry and exit motion to detect if the motion cuts into the part when machining an inside contour. Overlap sets the lead out move to occur after a set distance beyond the start of the cut, ensuring that no marks remains on the part. Line sets the relation of the entry line to the first entity in the profile or to the lead-in arc if one is specified. Length can be set as a percentage of the tool diameter or by entering a value in the field to the right, which is a distance in inch. Entering a value in one field automatically will update the other one. Ramp height sets the incremental Z height of a leading line. Arc sets the arc radius and sweep angle. Helix height sets the incremental Z height of the leading arc move for both start and end. Most machines will not allow cutter compensation to be turned on off with an arc move. You must also provide a small line move to activate G41, G42, and to turn off cutter compensation, G40, at the end of the cut. Use entry point causes the tool to start the toolpath at a point on its way to the entry move. This requires you to chain the point before chaining the profile to be machined. You can use the same point as exit point once the profile is machined, or you can select another point as the exit point. If use point depth is selected, the tool moves to the point depth at the XYZ coordinate of the point and then feeds to the lead-in move. If not selected, the tool moves to the XY coordinates of the point and the depth of the cut before feeding to the start of the lead-in. Adjust start end of contour extends or shortens the LeadInOut move by the value specified. More commonly used when machining open contours. These are the most commonly used LeadInOut moves. As you could see, you can have a combination of tangent line and arcs for both entry and exit. The small LeadInOut line is used to control cutter compensation, and the arc move blends the tool smoothly, leaving no tool mark. Perpendicular line entry and exit is used when the tool mark is not a concern. Tangent lead in, perpendicular lead out, used when you want to enter on a corner, and you do have the roll cutter around corners enabled in the contour parameters. I already opened LeadInOut MasterCam file. As you could see, the file already has 7 contour operations created. In each of them, I'm using a different LeadInOut option. In the first operation, I am using the contour toolpath to machine the outside profile using a 1/2 inch flat end mill at a depth of 1 inch. I did not use depth cuts as I'm just explaining the LeadInOut parameters. If we go inside of the parameters in the LeadInOut page, you can see that for this operation, I have entry-exit at midpoint enclosed contours selected, which tells the system to move the starting point, which was selected at this corner, to the midpoint of the first entity along the chain that I selected. Gouge check is disabled, as for outside profile, the gouge check will not be doing anything for the toolpath. I also provided an overlap distance, which you can see it reflected in the toolpath. The lead in and lead out are not starting and ending at the same point. We have the extra 100 thou between them. In the entry, I'm using the line tangent, and I set it up to 60% of the tool diameter. And I also provide an arc entry with a radius of 30% of tool diameter and a sweep angle of 90 degrees. The same settings are in the exit. I'm just going to use backplot to check the toolpath, just to show you what's going on here. And I will concentrate on lead in, lead out movements. I'm going step by step. You can see the line tangent to the arc. Then the tool goes around the part. And then here it was creating the overlap with a distance of 100 thou. And then it exits with the arc, line, tangent, and goes back to the retract position. In the second operation, I'm using a perpendicular lead in and just the line is selected. The arc radius was set to 0. If we check the parameters again for the lead in out, you can see in the lead in out I have still the entry exit at midpoint enclosed contours. It starts at the midpoint of the first line. Gouge check, it won't do anything for this toolpath. I can disable it. As far as entry line goes, I set it to perpendicular, and same line perpendicular was set to the exit. And I left the length to 100% of the tool diameter, which in our case is 1/2 inch. Arc radius was set to 0, and no other options were used. I'm just going to backplot this toolpath, again, just step by step. And you can see the perpendicular line, and the tool will go all the way around. Remember, with this option, you will see a mark on the part once the finish operation is done. On the third toolpath, I am starting the contour operation at the corner. And as you could see, I have a lead-in tangent, and the lead out is set up to perpendicular. Again, I'm just using the line entry and line exit. If we check the leading out parameters, you can see that the enter, exit, and midpoint in closed contour is disabled. And in the entry, I have the tangent line option, no arc, and in the exit, I set it up to perpendicular. When backplotting the toolpath step by step again, you will see how the tool engages with the line tangent to our profile. It goes all the way around. I do have in the contour operation the roll around the corners option turned on. That's why you can see that arc, and then is exiting with a perpendicular line. Okay, for now. The fourth contour shows you inside contour operation. And in the fifth contour, I have the same inside contour operation. You can see that on the fifth operation, I'm basically gouging into the part with the lead-in, lead-outs, while on the fourth operation, those lead-in, lead-outs were trimmed to have the gouge check protection. I'm starting with the fourth operation, and what is important here is that I set up this gouge check. As I said before, this works for inside profiles. And the rest of the settings, I'm just using the most commonly used lead-in out options using the line tangent and an arc with radius and sweep angle setup. Same settings in the exit. When backplot this, you will be able to see the tool engaging the material. It's kind of close to the wall, but it's not touching that wall, and it will exit in the same way. The line was trimmed for this operation. In the fifth operation, I removed that gouge check option. As you could see right now, it is disabled. And if we backplot right now the toolpath, you will be able to see how right from the entry is gouging into the part with the lead-in, and it will also gouge at the exit. In the sixth operation, I'm machining an open contour, and in this case I'm not using the entry-exit options. Instead, in the lead-in out, as you could see, entry and exit are disabled, and in the lead-in out I have the adjust start and adjust end contour turned on. I have it set to extend the length 100% again of the tool diameter, which in our case is 1/2 inch. Basically, in this case, Mastercam extends the start and the end of the contour. It's going to be a tangent line in both cases, 100% of the tool diameter, so 1/2 inch, and instead of the entry-exit, I'm using this option. The last contour operation, I am using a point where I want the tool to start the toolpath from. As you could see in the geometry, I have two chains. First, you need to select the point, and then you have to select the chain. In the parameters, you need to have the use entry point, use exit point enabled. The entry exit, I set it up to perpendicular, in this case 60% of the tool diameter, but of course you can use a combination of lines and arcs depending on how you want to machine the part. Just going to quick backplot the toolpath. So if we go again step by step and zoom in, you can see the tool enters right at the point. So it moves in X and Y to the point, and then it's going to the final depth and adjusts an entry and then makes the line perpendicular to the profile. My starting position had to be quite close to the point. Just to show you the selection needed for this toolpath, I'm going to delete the operation, and then I'm going to redo the contour. You need to be in wireframe mode, and from the selection method, I'm going to select point first to select the point where I want to start, and then chain option, and I'm starting the chain with this line. I want to move the starting point to somehow align it with the point where I want the tool to first start this operation. So the starting point can be moved dynamic. I can just go into a top view so I can better see where I want the starting point to be. Kind of eyeball, I'm just going to click here, okay. And then in the LeadInOut, I want to use entry point, use exit points. And the line should be set up to perpendicular in both of them. In the linking parameters, I'm going to set the depth to incremental and 0. I'm just going to go step by step. You can see the tool is right above the point, steps in. I needed to adjust because the leading set to 100% of the tool diameter was bigger than the distance from the point to the contour. I could use a smaller distance in the leading, probably 60% of the tool diameter, to avoid that extra movement there. Regenerate, and now we can backplot it again. If I was making the point exactly at a specific distance from the starting point, no extra movements will be created. And this concludes our video about the LeadInOut parameters.